What we're going to look at in this video is calculating the equation of a tangent at a point on a curve. So calculating the equation of the tangent at a given point on a curve. Now think back to when we did straight lines and tangents. Try and refresh in your memory what a tangent is. You remember? Well, if you don't, here you go. So a tangent is a line which touches a curve at one point. So if you look at the diagram here, a tangent, the red line, touches this curve which I'm calling y equals f of x at the point t. Then shoots off to infinity or minus infinity, and that's what it does. Now, a curve can have more than one tangent. So the curve can have tangents going here, coming down this way, going across, and they can intersect each other by all means. That's not a problem at all. But a tangent is touching the curve at one point there like that. Now, what we have to be able to do is calculate the equation of this tangent. Now, if we remember rightly, the tangent is a straight line. And to calculate the equation of a straight line, we have to use a formula we covered in straight lines, which is y minus b equals m bracket x minus a. So that's the formula we want to use for calculating the equation of a tangent or straight line at one point. Now, in this we need two key things. We need the coordinate AB and we need m, which was the gradient. So we need the gradient as well. Now, AB can be taken from any point where it touches. So in this case, if I was to get the equation of this tangent, my AB would be taken from the point T where it touches. The gradient, however, is slightly more tricky. Now, to normally calculate the gradient of a line, we need 2 points, because we need to use the m equals y2 minus y1 over x2 minus x1. However, imagine we had this scenario here, and I only gave you 1 point. How could I calculate the gradient of the line if I only have a single point? Well, think what gradient means. Gradient means a slope, and if you look at a line and you're looking at the slope of a straight line, that's telling you how things will change as they roll along the line. So the gradient tells you that, which means the gradient is the equivalent of a rate of change. So it's the equivalent of some sort of a rate of change of the line. And we've covered something that describes the rate of change. We've covered the derivative. So what we know is the rate of change is the derivative, which is the gradient. So to get the gradient, we take the derivative, f dashed of x, or dy by dx, depends on the form of the function. And we then calculate it at the point c. So in this case, we take whatever the value of x is, once we've calculated our derivative, substitute it in, and that gives us the gradient of our line. Once we've done that, we're then able to calculate the equation because we've got all the information we need. We've got our gradient, and we've got a given point somewhere on the line. We need those fundamentally. So I'm going to show you a couple of examples of what I mean by this. So the first one, find the equation of the tangent to the curve with equation y equals 4x squared plus 2x minus 1 at the point x equals minus 1. Again, remember the two things. We need a point AB and we need our gradient. Now, looking at this, we actually don't have the point AB yet. We only have part of it. We've only got the x equals negative 1, so we know A is negative 1, but we don't have the B. However, we're told this is the curve here. So we know whatever this point equates to on the tangent, it will be the same on the curve. So to get the full part of the coordinate, the B part, we substitute in here. So what we do in this case is we get y equals 4 bracket negative 1 squared plus 2 times the negative 1, take away 1. And we calculate that. So 4 times negative 1 squared, well, negative 1 squared is 1. So that's 4 times 1, which is 4. 2 times negative 1 is negative 2. And then it's take away 1. So 4 minus 2 minus 1 is 1. So what I know then is my point AB is given by negative 1, comma 1. I've used the information I've got, the x value, to calculate what the y value is. What I now need to do is calculate the gradient. Well, remember, we said the gradient was the derivative. So in this case, it's going to be dy by dx at the point x equals negative 1. So what I have to do is figure out what the derivative is and then substitute it. So think back to when we did the basics of differentiation stuff, how we calculate the derivative of this. Bring the power down, reduce the power by 1. So if y is equal to 4x squared plus 2x minus 1, derivative becomes 8x for the first term, and this one here being plus 2x simply becomes plus 2. The minus 1 is just a constant. When we take the derivative of a constant, we get nothing. So we've got 8x plus 2. What we need to do is substitute in x equals minus 1. And what that means is our gradient is equal to 8 times negative 1 plus 2. 8 times negative 1 is negative 8 plus 2. I know my gradient is negative 6. Now that I've got that, so I've got my gradient and I've got my AB, what I'm able to do is substitute in. So I know y minus b equals m bracket x minus a. And I could put the information in there. So y minus 1 equals negative 6 bracket x minus a, so it's minus minus 1 plus 1. And then we just multiply it out and write it in the form we want. So y minus 1 equals negative 6x take away 6. Y equals negative 6x minus 5. There you go. There's the formula for your straight line. If it asks for it in the ax plus by plus c form, this would simply be y plus 6x plus 5 equals 0. Both mean the exact same thing. If you left it in this form though, you'd be perfectly fine unless it specifically asked for it like this. Calculating the equation of the tangent at a point is fairly straightforward. We just need to remember this is the information we need. We need the point of intersection, we need the gradient. Sometimes you're given bits of information and asked to calculate other things relating to it. So in this one, I want to find the points of contact of this curve when the gradient is equal to 8. So I want to know where it meets here when this is equal to 8. Now we know that the gradient is the derivative f dashed of x, but we also know the gradient is 8. So what we want to figure out and solve is when f dashed of x equals 8. So we take the derivative, so there's f, so let's do f dashed of x just below it. Power down, reduced by 1, 3x squared, and then that becomes take away 4. So substitute all this in, we get 3x squared, take away 4 equals 8, and then it's just a case of solving it. So add 4 to both sides, 3x squared is 12, x squared is 4. This is where sometimes people make a little bit of a mistake, because at this point, x equals 2, or negative 2. Remember, if you take the square root of 4, the square root of 4 could have been 2, or it could have been negative 2. Negative 2 squared gets rid of the negative and gives you the 4. Don't forget that little factor there. If you're taking the square root, remember the positive and the negative values. So now I've got the x part of the two coordinates. What I now want is the y part, and the y part I get by substituting in here. Remember the last one, we had y equals. Well, we also know that y equals f of x. So y is the function at that point. So to get y, what we do is substitute each of these in. So if I have x equal to 2, I put it in there, I get 2 cubed, take away 4 times 2, 2 cubed is 8, 4 times 2 is 8, it's 0. At negative 2, I get negative 2 cubed, take away 4 times negative 2. Negative 2 cubed gives me negative 8. Take away 4 times negative 2, so that's minus minus 8. That becomes plus 8. That also equals 0. So what that means is that 2 points of contact, 2, 0, and negative 2, 0. Now that might look weird. I've told you a tangent touches at one point, but think of the shape of the curve. The x cubed minus 4x looks something like that. Now if you think of the gradient being 8, what you know is the gradient will be 8 at one point here, 2, 0, but it'll also be 8 there, where the line is, the parallel lines. So when you get curves of this shape, it isn't uncommon to get two tangents with the same gradient. They'll just be further along the line from each other, so they won't meet. Sometimes you get tangents that do meet, but if you're asked to calculate the point of intersection of two different tangents on a line, we know how to do that. If you can't remember, go back and refresh your memory with the straight line stuff, because that's where all this starts to come into play now. We're bringing all the different units together. So, working with the gradients and tangents of our curve, fairly straightforward. Just don't forget the key bits of information you have to know how to calculate and have to work with.